Hello everyone. In this video, we will see about the exploratory data analysis, starting with how to construct a bar graph with overlay using Python. Import matplotlib.pyplot as PLT. This imports the pyplot module from matplotlib, which is used to create visualizations like graphs and chart. Import numpy as np. This imports the numpy library, which is commonly used for numerical operations. It provides an array object and useful functions such as np.arrange for creating arrays for evenly spaced values. Now category is equal to this list. It represents a list of a category labels for the x-axis of the bar chart. And this values 1 and values 2 are the list of data values that corresponds to each category. This will be plotted as a separate bars for each category. Now x equal to np.arrange. It is used for bar position. It creates an array x with evenly spaced values from 0 to length of a categories minus 1. This array will be used to position the bars along the x-axis. Width equal to 0.4 sets the width of a bars to 0.4. This width controls the thickness of the bars in the chart. Create the plot. Now, this creates the first set of a bars, values 1 at a position x minus width divided by 2. Label equal to value 1 assigns a label for the legend. Color equal to blue sets the color of the bars to blue, and alpha equal to 0.7 makes the bar semi-transparent. Now this creates the second set of bars at position x plus width divided by 2, shifting them to the right by half the width so they appear next to the first set. Label equal to value 2 assigns a label for the legend. Color equal to orange sets the color of the bars to orange, and alpha equal to 0.7 again makes the bar semi-transparent. Now plt.x label category adds a label to the x-axis, naming it to category, and adds a label to the y-axis, naming it values. plt.title bar graph with overlay adds a title to the chart. plt.xticks sets the x-axis tick mark to correspond to the category labels defined earlier. plt.legend displays the legend that shows the label of each bar set. plt.tight layout adjusts the padding between the plot elements so that they fit within the figure area without overlapping. And plt.show displays the final plot. So after running this code, plt.show will display the plot like this. So the first set of bars having color blue and the second set of bars having color yellow. Okay, now moving on to the second, how to perform binning based on predictive values using Python. Import pandas as pd used for data manipulation. Pandas library is used for data manipulation. Then from sklearn.tree import a decision tree classifier. This imports the decision tree classifier class from a sklearn. This class is used to create a decision tree model that can be applied to a classification task. Now from sklearn.processing import kbeans discretizer. This imports the kbean discretizer class from sklearn. Now data equal to pd.data frame creates a pandas data frame called data, having a name data with two columns, feature and target. Feature, a continuous feature that will be used to group data into bins, and target, a target variable 0 1 that will be used to train the decision tree and define how the data is binned. Now predict bin label. Decision tree for binning based on target. Tree equal to decision tree classifier. Decision tree classifier with the parameter max leaf nodes equal to 3, which means the tree will be allowed to have at most 3 leaf node. This will limit the number of beans or categories that the feature column is split into. Each leaf node represents a separate bin. And tree.fit fits the decision tree model using the feature column as the input data and target column as the target. The decision tree will learn how to classify the data into three bins based on the feature values and their corresponding target values. Now tree.apply. The apply method is used to predict which leaf node each data point belongs to based on its feature value. The result is an array of integers representing the index of the leaf node that each data point belongs to. Now data feature bind feature and target. We will print the data frame with the feature bind feature and target column. This shows that the original feature values, their corresponding bin labels, and the target values. And after running this code, we will get the following output. Now, third, how to construct a contingency tables using Python. Import pandas as PD. Now again we will import the pandas library, which is commonly used for data manipulation and analysis in Python. It is used here to work with data frames and create a contingency table. Now example data. A dictionary is defined with two keys, gender and preference. Gender represents the gender of individuals with values male and female, and preferences represents their preferences for some category with values A and B. Now df equal to pd dot data frame. This converts the data dictionary into a pandas data frame. The data frame df will have two columns, gender and preferences, each with the respective values from the dictionary. Now hashtag create the contingency table. Contingency table equal to pd dot cross tab. This function creates a contingency table between the gender and preference column. It counts the occurrence of each combination of gender and preference. Here is how it works. The row represents the unique values from the gender column, that is either male and female, and the column represents the unique values from the preference column, that is A and B. The values in the table represent the count of how many times each combination of gender and preference occurs in the original data frame. Now print contingency table. This prints the contingency table to the console, displaying the relationship between the gender and preference. Here in the output we can see that female has a only one female has a preference with A, two female has a preference with B, and two male have a preference with A and one male has a preference with B. So this was all about the exploratory data analysis. Thank you for watching.